Welcome at this Prespective beginners tutorial. I'm going to show you how to complete the wrench tutorial. So let's begin with showing you what the end result should look like. In the wrench tutorial, you need to create the kinematic setup where the wheel joint on this screw game object is connected to a prismatic joint on the jaw, so that this movement is possible where you move the jaw up and down and the screw component rotates along with it, as well as the other way around where you rotate the screw and the jaw moves up and down with it as such. Okay, so you have two scenes in the tutorial. One is the finished scene, the one we're in currently, but we're going to go over to the exercise scene, and here you will find the wrench game object but without the kinematic setup on it, and you will need to create the kinematic setup yourself. Here you will find also a detailed description on what you need to do for this tutorial. Here you find the general description of the wrench tutorial, and it says the steps we need to take in order to complete the tutorials. This tutorial are: create a kinematic controller, then add a wheel joint to the screw game object, then add a prismatic joint to the jaw, and then create a kinematic relation between the screw and the jaw with the realistic translation in mind. And that means that make sure that these teeth don't clip through the screw, but we'll see that later how that works. Okay, so let's begin with step 1. Oh, by the way, each individual component is also explained here in more detail, how to work with wheel joints and prismatic joints and everything you need for the tutorial. So let's go ahead with step 1, create a kinematic controller. To create a kinematic controller, make sure that you have nothing selected in the hierarchy like so, and then go to mechanics and then add kinematics and then click kinematic controller. And this will add a new kinematic controller to your hierarchy. If you did select a component, then the kinematic controller component will be added onto that selected game object. We don't want that for now, so we had nothing selected. The kinematic controller controls all the kinematics parented underneath it. So to make sure that everything is under the kinematic controller, we're going to parent the entire wrench on the kinematic controller as such. Okay, so that's step 1 already done. Then for the second step, add a wheel joint to the screw. Then we're going to select the screw this time, and if we go to the explanation about the wheel joint here, you can see for the wheel joint to add one, go to mechanics, add kinematics and wheel joint. So we're going to select the screw, mechanics, add kinematics and then wheel joint, and this will add our wheel joint component onto the screw game object. This will draw this seemingly huge gizmo. This wheel joint is by default generated with a radius of 1, but we're going to bring it back to 0.02 for now, so that we can see it more clearly. And then what we need to do also is set up the axis and the forward direction for this wheel joint. This blue circle indicates the plane over which the game object is allowed to rotate, and as you can see, it currently is not aligned with the actual axis that this screw would rotate over. So we need to set the axis and the forward direction. To do so, here in the wheel joint settings, you go to wheel axis direction and the wheel forward direction, and you can find these scene vectors, and these will allow you to set the axis and the forward direction. So let's begin with the axis direction. It's currently set to the vector space local parent, which means that it will track the vector space of its parent, which is the handle. But since it's not properly aligned with the handle, but it's under an angle, we're going to change this to local child, which means that it will look at directions relative to itself. Then we need to change the axis direction, and we're going to set this to forward. And as you can see, the plane now shifts and it immediately changes into the right plane. So this custom vector is actually right, I believe. Yeah, as you can see. So it just changed. That's because it's the same. Go to left and then right. No, it doesn't want to. But anyway, it's in the proper position. And the plane is now set up. But if we try to rotate this over this axis, it still allows this movement. And that's because the wheel joint currently isn't enforced, because we are in edit mode. If we go to play mode, then this will work. What we can also do is check this box and enable enforce outside play mode. And we can see that this now is allowed to rotate over this axis, but no longer is allowed to move over this axis. And it's now constrained on the green axis you see here. And that's currently everything there is to setting up the wheel joint, and that is step 2 completed. The next step is adding a prismatic joint to the jaw, and the jaw should only be allowed to move up and down like this, because that's the only movement this slot would allow for. But we can of course move like this also at this current moment. To add a prismatic joint to the jaw, we need to go to Mechanics, Add Kinematics and Prismatic Joint. This time I'm not going to use the menus up here, but we're going to use the context menu. If you right mouse button click this, then all the way at the bottom you find Add Kinematics, and then you can add the same kinematics as well. As we're going to add the prismatic joint, and we'll add the prismatic joint to the jaw game object. A prismatic joint needs a spline to describe the path it's allowed to follow, which will constrain it to that spline. And to create a new spline, make sure nothing is selected, and then go to Utilities, Create, and then Spline. This will add a new spline to our scene. If we zoom out, we see that a spline is by default generated with 2 points, and these points are 0, 0, 0 and 1, 0, 0 in the global space. If I select the point 2, I'm going to bring this in already, so that is matching this slot length more precisely already. And I'm going to move this over here so that it's closer to our wrench. We need to position our spline so that it describes the constrainment of the slot there where the jaw is currently in. I'm going to disable this jaw so that we can't see it, and then I'm going to change our shading mode to shaded wireframe. This allows us to see the vertices on the mesh, and that also allows us to position these points precisely on the vertices. If I now select point 1 and I want to move this onto a vertex on the mesh, I hold V and I'm going to drag it, and it automatically snaps to that vertex. We want to align this spline with this slot, and I'm going to have it aligned with this line on the mesh, because that perfectly describes the slot. So I'm going to zoom out a little bit, and then point 2 is visible, and this vertex here also. Select point 2, hold V. If it doesn't, click first and then hold V. Okay, and then drag it onto that vertex like that. And if I rotate my camera, I can now see that it actually is positioned properly. Okay, great. I'm going to enable the jaw again. Then this spline, I'm going to parent it under the same parent as the jaw. So this jaw is currently parented under the handle. So that means I'm going to parent this under the handle as well. I'm going to place it right above the jaw. Yes, like that. And I'm going to rename this jaw spline for now. Okay. Then if we go back to the jaw, we still need to assign the spline to the prismatic joint. As you can see here, there's currently no spline selected. If I drag this jaw spline in, this spline is now assigned to this prismatic joint. Again, it's still allowed to move everywhere it wants, because we haven't enforced it outside plane mode. So if I click this now, you can see it's now constrained to the spline. We can move over this direction, but not anymore in this direction, nor in this direction. Okay, great. Next thing we need to do is, now that the prismatic joint is set up, is we need to create a kinematic relation between the screw and the jaw, and with that in mind, the realistic translation, that means that these teeth need to move along with the coil exactly, not so that they don't clip through each other. To create a kinematic relation, and I'm going to change back to shaded for now. If we go to the prismatic joint, then you will find the kinematic chaining here. Let's create a new leading transform relation by clicking this button, and it adds a new relation. Let's fold this open, and then it asks for an opposing relation instance. That's the kinematic transform you want to create the relation with. So the prismatic joint wants a relation with the wheel joint, so we're going to drag the screw where the wheel joint is onto here, and it finds this wheel joint. We're going to leave the direction to bidirectional, which means that if we move the prismatic joint, the wheel joint moves along with it, but also the other way around. We can set this to receive or send only if you want to have it only work in one direction. And we may have to set this to reversed, and we're going to check that now, because if we move the jaw up and down, we now see that the screw moves in the opposite direction. The jaw moves down and the screw moves up. So we need to set this to motion direction is reversed, so that if this moves down, the screw also moves down. So the relation is now made, but as you can see, the proportions aren't right, because the jaw moves down faster than the screw. To have these align, we need to change the circumference of the wheel joint, because the circumference of the wheel joint is directly related to the distance traveled over the spline. The distance between these teeth, and with that I mean from this point, from this teeth to that point on that tooth, should be equal to the circumference of the wheel joint. And if you calculate the circumference, then the radius should be 0.0008 for this setup. If I now move this jaw, we should now see that the screw moves along with it at the same rate, as you can see here. But it still clips. It clips through. So I'm going to close the jaw completely, and then we want to reposition this so that it doesn't clip anymore. I'm going to select the screw again, and I'm going to disable enforce outside play mode, because this will allow me to rotate the wheel joint without the prismatic joint moving along with it. I'm going to rotate it so that this coil now aligns with the teeth, and that is like this. Yeah, okay. I'm gonna re-enable enforce outside play mode, and if I now move the jaw down, we should see that these are properly aligned. Yes. Okay, so we have the relation set up, and the proportions are right. Then there's only one thing left we need to do, because if we move the joint down, we see here this should be a hard limit, because this is a point where the screw would be jamming against the jaw. So we need to make sure that the prismatic joint wouldn't be allowed to move further than this. Currently we can still move a long way down, so we're going to position this on its limit point, so that's approximately this, and then we're going to our prismatic joint, scroll down, and then we find the spline settings here. This 0.1 should be the very limit of our allowed movement. So we want to reposition this to our current position, since we are now actually at our lower limit. Select 0.1 and then click update limit control point, and it now repositions this point 1 to here. So now we can no longer move beyond this point. With that completed, we have now a fully working wrench. So we have created the Kinematic controller. It controls the wheel joint and the prismatic joint and its relation. We have a fully working wheel joint, a fully working prismatic joint with realistic relation between it. And that concludes our wrench tutorial. I hope you have learned something from it, and if you would like to try this tutorial yourself, you'll find a download for it in the documentation of this tutorial.